Yeah, good morning, students. Can am I audible to you?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir. Good morning, sir.
Yes,
Good
sir.
morning, sir.
Good
Yes,
morning.
sir.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Good morning.
Good morning,
Good
sir.
morning, sir.
Good morning. Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Good morning. So in the last class, what we are discussing at the point where we left is that engineering graphics is one of the ways to represent your technical details in a proper way, and that has to be standardized in a such a way that it could be understood throughout the world. So for that one, we need drawing sheets where we draw different types of drawing, and based upon the sizes, the drawing sheet starts from bigger size, that is A0 size, and it ends up to A5 size. Generally, what we see is that when we go from this bigger size to the smallest size, so what happens? The length becomes half, then again this width becomes half, then again length, then width. In this way, the sizes are defined. So we generally tend to use this A4 size papers for day-to-day life, and for drawing we use bigger sheets like A2, A1. Sometimes A3 sheets are seldom used. We use A3 or A1 sheets. Now, uh, we discussed that what is the need for use of trimmed size and untrimmed size, because the papers which comes from out of the mill, actually they are being handled at different processing times, different stages of processing before reaching to us. So the untrimmed size are paper mill size, where they come out from the paper mill, and then they are trimmed to specific sizes, after which we can use in our drawings. And we also learnt about various layouts of the drawing sheets, the sizes, the margins, the necessary border lines, the untrimmed sheets, the margin, and the trimmed sheets with title blocks. Also, we saw in video on how foldings of drawing sheets are drawn. So these are something that we had learnt in the last classes. Also, the centering marks are important in order to place your drawing in the center. This is the drawing space. This is the orientation marks, which shows that what is the orientation. So this basically these are why these are made, because if you want to have a grid reference, so you need to draw these lines, and if you want to have a graph represented, or you have to draw a unit volume or something like that one, then you have to do this grid thing. Yeah. So after this one, the title box. The title box, as we saw, it is placed at this. This is the end where we represent all the necessary details about the drawing and the person who has drawn this diagram. So in this one, actually, the title box is an important feature, which in any of the drawing sheet represents technical and administrative details. So this is generally placed at bottom right corner with a dimension of 160 mm into 60 mm. 60 mm length and 60 mm length and 60 mm height. 160 mm length and 60 mm height. So this is 160 and this is 60. And what happens? It is divided into two zones. First is the identification zone. What is the identification zone? It is basically related to the administrative detail, where we write the registration number and identification number of a person who is drawing that one, the drawing title, as well as the name of the legal owner of the drawing. That is the name of the firm or the company or the person who is drawing this type. So one part is the identification zone. The second zone, what we have is the additional information zone, where we indicate the items, the symbols, systems of projections. If you want, we'll learn what is projections actually, the scale and everything. Other technical details, for example, the geometry, the texture, the tolerances, if you have any, and other administrative items. So all those things are divided or written into that small box that we see of 160 into 60 mm dimension. So this is the part where we write everything in 160 and 60 mm dimensions, all the name, detail, and some descriptive, small description of the drawing, so that it could be understood that what is the drawing is all about. So, so this is the layout of a drawing sheet, which we have already seen. The trimmed border. This is the trimmed part that we do in our what we get as a drawing sheet in the market. The borders. This is the frame line, and this is the title box. We have the centering on all the four sides so that we can draw anything on the center. This is 170 mm maximum which is given. So 160 is, into 60 mm is the maximum, is the standard one. You can go up to 170 mm. And this is how the title box look like. So in this one, what we have is the first is the name of the institute, NIT Raipur, then the name of a person, Shruti Serha, the title of the diagram, that is lines and lettering, roll number, seat number. What is the seat? Because we do number of seats. If a drawing is if we are doing any complex drawings, so what happens actually, we divide the drawings into number of different seats. So in this way, the seats are also numbered as 1, 2, 3, and 4. This is the gate what we give actually, the branch, date, and the signature. So these are the some specific details that we write. All the other things that are written here is example, what are the types of projection, which is not shown here, but the types of projection, how it is done, or in what quadrant that is done, everything is being written in this title block. Now, once we have gone through the drawing sheets, now comes the drawing pencil. So the pencil is one of the important factor here, is that because when we draw certain things, we need to draw something bold, something lighter, sometimes smudge type. So everything depends upon the type of pencils we are using. So we have extra hard, extra dark pencil, light pencils. We have different grades of pencils. So the accuracy and appearance of a drawing depend largely on the quality of pencils that we use. So if you use any non-standard pencils, so it will be very difficult to get that exact that deftness of the drawing that you want to represent. So wooden pencils that we use generally are graded and designated by numbers and letters. It starts with 7B, 6B, 5B, 4B, 3B, 2B, and B, and this is in the decreasing order of their softness and blackness. Then after this one, what we have is that we have medium grade pencils, that is starts from HB pencils to F grade, and then from medium, when we go for harder pencils, we have this H, 2H, 3H, 4H, 5H, 6H, up to 9H, where we have increasing order of hardness. So this 9H pencil is very harder, and this is the 7B pencil, which is the softer one. So drawings what we do are usually drawn in 2H pencils, and then means this medium hard pencils, medium grade hard pencils, and are finished with H and HB pencils. So we do not tend to go on this very much harder one, because if you go for a harder one, then it will put impressions on your drawing sheets. So that is not required. We require some of the drawings, because sometimes what we do when we do the drawings, we need to erase something sometimes. So for that one, we seldom avoid a harder grade pencils. Rather, we go for the softer grade pencils, starting from HB to 2H grade. So this is the most practical range to be used in drawing pencils, HB to 2H. Now, Now we have once we have selected the pencil, it is also important to select the lead type. What is the lead design that you want to give? Now there are two edges that we see generally. One is the conical one, this one conical that we normally get in a sharpener. The other one is the chisel one. Chisel one means this types, the chisel edges. Now chisel edges, why they are used? For example, if you want to have a conical, which is a simple pencil, after what we get after sharpening, we do it for the sketch work or for lettering. This is just a conical application. You do any type of sketch working or any lettering if you want to write, that is done with the conical pencil. And if we want to use a chisel edge, we use chisel edge only for drawing long thin lines of uniform thickness. And that can be easily drawn with this one because chisel edge has got this, this tip, this what you are seeing a file, the straight squarish tip. Now for that one you can get a, if you draw with that edge, actually you will get a thick line, and that will be more or less uniform. Because this one will actually, this is the pointed edge. If you are going to draw a thick line, then this will actually wear out after some point of time when you are going to draw thick lines. But this one, because this edges has got more kind of a flat appearance. So what happens is it helps us to draw parallel lines or uniform thick lines for a longer duration. So that's why if you want to draw thin lines, we use this chisel as one. And if you want to do any small type of sketching or lettering, we use this type of pencils. Now in finished drawing, what happens? All lines. But when we drew any type of finished drawing, all lines except the construction lines. But we will tell you what are the construction lines. Construction line are the foundation lines, we can say, which need not to be shown. It is a kind of a things which are present inside, and it needs not to be shown. So in a finished drawing, when the drawing is complete, all lines should be dense, clean, and uniform. This is the main requirement. A finished drawing will have all the lines to be dense, clean, and uniform. The construction line should be drawn very thin and should be hardly visible in the finished drawing. They should not, but they should not be erased. So I will tell you what is the construction line, how it looks like. So one thing is that the construction line should be present, but it should not be present in such a way that it will be representing the main part of a diagram. Although they form the foundation part of the skeleton of a diagram, but they need not to be represented in a dark lines. So for that one, we use a pencil grade, which would be, or a line type, which would be hardly visible to the finished drawing. Now, for that one, what we have is that we have two types of, line groups. That if we have a 0.2 mm line thickness, this is the thickness of the line, which is the medium thick. We use this one for drawing outlines, dotted lines, or cutting plain lines. If you have a zero point 0.1 zero point 0.1 mm. This is the thin line, the center line, section line, dimension line, which is the lines which are used to represent the main, some of the very important features in a diagram. For example, the center line, the reference line, the section line, the dimensioning parts, the extension lines, all those lines are being drawn with a very thin one. So these two line groups are very much important to understand, to show the or represent something in a drawing. So that's why even if you have selected a pencil, good pencil like chisel edge or pointed edge or conical edge, you need to be very careful that when I'm doing any diagram, it should be representing the main, whenever a person looks into the diagram, that if it is a center line, section line, whatever the way the pencil has been used to draw a diagram, it is very important. So thin lines are with a thickness of 0.1 mm is generally used for these types. It is very important to draw these or represent these things with a thin line. If you want to have a outer outlines, dotted lines, or cutting plain lines, we can have this 0.2 mm. For example, even if you see this one, this diagram, if you consider this as a diagram, we have the outer line as a very thick line, you can see, whether the inner lines are being represented by very thin lines. So this could be an example of a using of two different types of things that has been done. For example, if you see a Google Map satellite image, you see the if you see from a top the borders of a different fields on the crop fields, it has borders which appears to be very dark. So those are the borders which says that this is the boundary of a particular plot of area. And whatever things which are present inside, those are represented by the thin lines. Could you understand what I wanted to say up to this point?
Yes, sir. Clear.
Yes,
Yes.
sir.
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
okay.
sir.
Thank you. So, so if anyone wants to ask the doubt, they can ask because what I am. If anyone would have been writing that in the chat box, I won't be able to see that one because I am in full screen mode. So now coming to the line types. Okay. Although we have defined the lines thickness to grade medium and thin, now the types comes. How the lines can be drawn. Now thin and thick also has got various varieties. For example, thick one is used to show the outlines, visible edges, and surface boundaries of an object. Now, if you want to have, for example, if you see this one only, the outline, the border of this thing is being shown in a darker line, that's the thick line. And continuous thin line, which is the dimension line, extension line, section line, or leader or pointer lines, or construction or border lines, are being shown by this continuous thin lines. So we'll see. This is an example of this one being shown by a thin line. The main thing is present is the boundary on the outer edge, what you can see, and this one what you see is the thin lines. What you can see is the continuous thin. Now there is another part of continuous thin line is the wavy lines. So these are short break lines or irregular boundary lines, and these are drawn freehand. It's very important to understand. These lines are drawn with respect to a scale by putting a scale or ruler, but these types of lines are drawn with a freehand because they need not to be have any particular symmetry. But it doesn't mean that I will be showing something like this one, and like this one, like this one. No, no, this is not correct. There is a particular trend. You can go like this way in smooth wavy curve, but not like this way. So there is a particular thing to show this, thin line. Similarly, continuous thing with zigzag. So zigzag also, for example, if I've shown this way of putting lines, so now this curve has to be like this way. It not to be present like this way. So this is not a correct way of doing. The zigzags has to be drawn in a particular, it's same like a ECG diagrams that we see in a monitor. So it is very important to see what each line represents. For example, continuous thin wavy line will represent short break line or irregular boundary lines. This zigzag line also it is drawn freehand generally. So this is called used for long break lines. We'll see what is break lines, what we are telling about in a drawing, and short dashes with gap of 1 mm and length 3 mm. So gap between each of the dashes is 1 mm and the total length becomes 3 mm. So up to this we do short dashes line to see anything which is invisible or interior surfaces. So it's like if you want to show the skeleton of your body, you can show this by the short dashes line. So this is one which is the invisible part. So this is the way of representing. And corresponding to each of these thicknesses, corresponding to each of these lines, what we see here, we have particular pencils associated with that. And although the if we are using a chisel edge or conical edges, the chisel edge will be used in case you are drawing chisel edges using chisel edges. The best way to draw this line is this one using the chisel edges. If you want to have a thin line, then you can use the chisel edge, but in an inclined position. In an inclined position. Also, you can draw this line with a conical one. This also conical one. This one also conical one. This one is best to draw with a conical one because these represents interior or invisible surfaces. So for each one, we have certain pencils defined. H, 2H, H, 2H, and 2H and H. So as we go on in this direction, we increase the hardness of our pencil. So this is very important that with respect to a pencil, a particular line is to be drawn in this type of a drawing. It is very difficult to remember all these things. What is this one? What is this one? But when you see the diagrams, it becomes very evident that from a specific diagram, let us take this example only. The box outline is being made by a thick line. The internal lines, which is a continuous thin line, has been made with a lighter shade, with a harder shade that is 2H. Now, the other dashed lines also include short dash like one break, one, you can see this one. There is one like this. If I zoom this one, it will look something like this way. A small dash, then again long line, then small dash, again long line. These are specifically used to represent the center lines and the locus lines. So they have alternate short and long dashes with proportion of 6 is to 1. So this is the ratio. So this is the ratio how the short dashes are drawn. And this represents the center of a diagram. Then this is the another line. This is long chain, thick at ends and thin end elsewhere. Means this is a kind of a kind of a two ends of a line which shows the cutting plane lines. If there is a plane which is present in a drawing, if you want to show that one, means you have to show that the diagram section of a diagram with the plane using that plane. You have to use the ends should be like this way. Okay, the end should be like this way and the end should be like this way, but the internal should be like this way. So it shows that we are cutting a plane. So this is one of the ways, and the other is continuous thick border line, which is used for borders actually. Although this can be used with that same thing, continuous thick border line correspond to the same thing as that of this one, thick line. But sometimes this is differentiated in a way that the thickness is somewhat less, and this is done with the HB pencil. So HB pencil is the medium grade with which we do this thick border lines. Now, now comes the drawing. Now we have learned about different type of pencils, the drawing sheets, and we have learned about the drawing where each of the lines has been used. Now, if you start with first drawing, it's a drawing of a block.
Excuse me,
Where,
sir.
yeah,
Sir, can we go one slide back? I have a doubt in the previous slide.
okay.
Sir, I wanted to ask that that cutting plane lines. What is the ratio of that small dash and big dash?
Yeah, the ratio of small back and this dash is closely according to 6 is to 1 ratio only. This
Yes.
one, this one, this one, or this one.
Sir, the cutting plane lines.
You see, cutting plane lines corresponding to the total one, this one.
Yes, sir.
This is the short dashes which is used to show center.
Yes, sir.
Short dashes has been put here with the ratio of 6 is to 1. The same ratio which is applied for this one also. So what happens? Let me show you one diagram actually. In this diagram, do you see this one? Do you see this one?
Yes, sir.
This
Yes.
line? So
Yes,
this
sir.
is the cutting plane line. What happens is that if you want to show the section of this one, so this is a plane, what we have done is that these ends have been put, the thicker ends are always put at the end and the middle edges are always put, the thinner ends are always put in this direction.
Okay, sir.
So in this way, we represent the cutting plane line. And if you want to show, just we have to project this and this one. If you want to, why we do the cutting plane lines, that it shows that if I want to project this section to any other part, in other way of representing. So this, with the help of this one, I can extend it, I can slow it. This is the purpose of using a cutting plane line. Now, always we do not have to stick to this particular ratio of 6 is to 1. This is just a representation. Sometimes when we do diagrams, we do not generally tend to have all the features included like 6 is to 1. But generally the trend is to have this 6 is to 1 ratio maintained throughout, so that it becomes evident that we have actually placed each of the lines means in each of the entities, for example entity 1 and entity 2, properly spaced and properly visible, so that it doesn't makes a confusion that if I am placing this line along with this line, the thicker one, thinner one, it should have a certain distinctness. For example, whenever we place these two lines, or the spacing you can see is somewhat different from these spacings. And of course, the spacings is different dependent upon the thickness of the lines what we have drawn. So that is somewhat what we take care in case of a drawing. So we use the thicker, hard pencils to draw this one, and when we do this one, we use the small pencil or means soft grit pencil, or either if you can do this one, use the chisel S, just draw a line like this one, and then rotate the chisel S, use the pointed edge of the chisel S to draw this. So this is the cutting plane line that we do. Now center line, as I said, like this one. This is like this one. So let me tell you, sometimes this is I thought there was a term called chain. Yeah. So chain dotted line. Please remember there is a term called chain dotted line. So chain dotted lines are something like this way. What is shown here, or in case of here, there is a chain dot like this way. So these are specifically used for representing the center lines. You can see the center line. This is the cutting plane. Moreover, so the cutting plane lines has been integrated with the short dash line. So this is the short dash line what we see, and this is the short dash line, but it has been integrated with the cutting plane line because they fall on the same axis. So that's why the center line and they are almost similar. Similarly, this is the outline which is drawn, the border line which is drawn. This is thicker, you can see darker, as well as we have this hidden lines which we do not want to show. So they are drawn in a lighter shades. This is again a center line. Why? Because there will be a bolt which will be sitting here. There will be a bolt which will be sitting here again. So that is not shown here. Sorry, it should be like this way. A bolt which should be sitting here. So that has been represented by a center line because this is the center of these two edges. And we do not see because this is a block which we are seeing from the front. So these things will be present inside of that one. So we won't be able to see this one. So this is the represented by a dashed line. Hidden lines are represented by dashed line. You can see the hidden lines as it was explained here. Short dashed lines are used for representing hidden or invisible surfaces. Now, this is the extension line what we do, extension line and the dimension line. So what is dimension line? Dimension line is something that we represent the dimension about. So this is 90. The unit is not written. We generally assume as 90 mm here. So 90 mm is the unit, is the length of this one, or 90 units if the unit is not present. This is the extension line to show that this is the dimension. Sometimes if we omit this one, just I have a block, I have drawn a block like this one, the same thing I have drawn here. Okay, this is the wrong way of drawing a drawing now. So this is not correct. The edges should be properly joined. Right. We should not have something crossed and like this way. This is not correct. So sometimes what will happen? So once we represent a dimension like this way, okay, 90 mm or 90 suppose. Sometimes what happens is this one the correct? If this one the correct, is this one the correct or this one the correct? So it becomes quite a confusing one. That what is 90 you are represented. Sometimes what happens is when we have sections like this way. For example, if I have a drawing like this way and I have drawn like this way. So sometimes what happens? This is I put as 45 mm and this is 45 mm. If my line somewhat exceeds this point, there is a gap here. So what happens is that it shows a kind of a incorrect way of representing. So that's why always from the borders actually we extend that one to show that this is this one. Here also we'll extend here to show this one, that this is 45 mm, this is 45. So that's why these extension lines are given to represent the dimension lines. So this is the way. And we have to understand that in a diagram, whenever we draw a diagram here or any drawing, it is always advisable not to show any markings or to avoid minimum markings or extension lines or lines from the within the drawing. For example, the dimension should be represented outside. All these whatever markings you are seeing all are outside the drawing. Nothing should be present on the drawing. Even if there is one minimum, what has to be shown here was the hidden line. So this is the thing that is to shown, or otherwise there nothing has to be shown on the drawing. It has to be outside the drawing because it should be clear in such a way that they should not understand, the person who is seeing you should not understand this is the part of a drawing. It's very important to show that. Similarly, here also you can see we have section line because if you want to show any part, cross section, the section if you want to cut and put it anywhere, the cross section and they are represented by this dash lines. Always the cross sections are represented by the dash lines, so the section lines are represented by a horizontal dash line at 45 degrees. This is very important. The leader lines are used for representing the dimensions. For example, circles and anything dimensions. Here also you see we have this center line here, center line here. This is the circle. This is the dimension that we are representing. And how see how the dimension is representing. The points has been put here, and then the dimension has been drawn up here to show 10, this 5, 10. Similarly, here also the locus lines what you are seeing, the locus lines also it has got two dotted lines, two dots to represent the locus lines. Straight lines are generally represented by one line dot, but locus lines are represented by two centers, two dots. So in this way, you see the short breaks line, how the short breaks line are drawn. Okay, short breaks line. What happens actually? This is a part of a long pipe or something or assembly of a machine. Now instead of representing everything in the diagram, because this section whatever we find here will be here also, this section what you are finding will be here also, this section what we find will be here also. So that's why instead of drawing so much of unnecessary this part, in order to save space, what we do is that we break this one. We understand that the other part is somewhat other. We have to represent in other diagram. This is the part where we have broken this one. So this is being represented by this dashed line, this wavy curve line, and the long break line, because the length part, it can go to certain lengths. So these are being represented by this zigzag line, which shows that this part is very long. This part is very long. So in this way, actually, we represent a different types of line in a diagrams. So let us go back into that part where we have, let me clear this part. And just let us see the types of line what we have seen here. The first line is the thick line, which is used to represent any type of uh, outlines or visible edges, surface boundaries or margins line, drawn with H pencil. Then we have continuous thin line, which is used to show the dimension, extension line on any section or leader points. Leader lines are used for showing the dimension of a circle. Construction lines or border lines, border lines. This is border lines, not the border lines. Then continuous thin wavy lines. This is used for using short break lines, the short break, short distance lines, and irregular boundary lines. Continuous jigs are used for long break lines. Short dashes are used to show invisible or interior surfaces. And then the short dashes with dot in between, these are used for specifically for centers and locus lines. Then this section cutting plane lines are used but are shown by long chain thicket ends and thin and elsewhere. Similarly, continuous thick border lines are shown by this thick lines with the border with using of SB pencils. So these are the uses of each of the lines what we see here. Now coming to the techniques, as I said, one of the technique I already show you what is the good technique and the good poor technique to draw a drawing. First is that the drawing should be drawn in a straight line, consistent line, ruler. It should not be something like hazy drawings. These are abstract drawings actually. It should be avoided in a drawing. Sharp corners, as I said, if you have something like this way, so it indicates that something is extending outward of this line. So this is not correct. So the sharp corners is very much important. The way the internal sections are represented, because if there is a passage here for a bolt to sit, a bolt has to sit here. So this has to be represented by this dotted lines and sorry, the dashed lines with center line present in between. And you see the difference between these two drawings. The difference is that we have something thicker at these points. So this should be avoided. Always the hidden sections are shown by thinner lines. It should not be represented by thicker lines. And also center lines are shown by thinner lines, not the thicker lines. So that's why if you see the proportion, this is thin. The border should be thick. So these are some of the differences that we need to understand when we draw the drawing. Avoid the inside lines or the line lines present within the drawing. For example, center lines or hidden lines to be drawn thicker than the outer border lines. Similarly, in this case, actually, what you see here is that there is a pocket here, and that pocket may contain any type of we can put any type of a rectangular bar here. which can be inserted here. And to show that because this is hidden, we use the dash line. But if I show this type of dash line, this is not correct. This we are what we are showing is a center. It's a kind of a center line what we are showing. No, this is not correct. It should be uniform. You see how it is uniform. Similarly, the centers. You see the center lines we have here. This is the center line. This is the line. Then dot. Then line. Then this is the line. Dot line. Here, what you see is that long line. Then again, this is small line. Then again, this is small line. This is like this way. This is that. So this is not correct. It has to be like this way, or like this way. Sorry, it has to be like this way or like this way, which is this one. Cannot be this way. Similarly, the edges. So we have learned the use of French curves, right? The French curves is used for drawing curves. So whenever we will have this drawing to be drawn, use the French curves to draw the arc or a protractor or compass to use those arcs. Do not do it by hand, because even if sometimes what happens, we put the protractor. This is drawn by protractor, but what happens? We do not select the edges in a particular way. What happens? It becomes like this. If you do not take the arc like this way, it will bulge out like this way. So this is not correct. Use the French curves to use these types of curves drawing. It will be useful in case protector is not proper. Now, when we come to the lettering, why we use lettering? Lettering is important because uh, once we have drawn the diagram, now the representation of the letters, whatever we have written, for example, lettering represents to this section. So these things, how the things are written. This is very important. We cannot just write, one thing written in a block letter, other thing written in a continuous small cases or lower case. So that has to be uniform. So lettering is a very important part. So if you want to write the title, subtitle, dimension, any other thing which has to be written, for example, name of the drawing, your name, company name, any other technical details has to be written in a particular standard. So it should be, the thing is that the lettering should be legible. It should be visible. Means you will be able to, person will be able to read that one. Just I can, my name is like, if I write my name is KalingaSimant and DL. If I write like this way, so it becomes very difficult to understand what the person is trying to say. So it is very important to write your name or represent something in a very particular way so that it becomes visible throughout. The uniformity. See how the uniformity is maintained here, that okay, there is a particular spacing between the two wordings. Here the spacing is not possible. So rapidity, how the pace it is being written, suitability for microfilming or copy. So everything has to be very much essential when we put a wordings or letters inside a drawing. We cannot just go on randomly writing everything. And it should be, it is not that if I have to represent, if this is my drawing sheet and there's a drawing here, okay, in the center, I my maximum concentration would be to write the everything here closer to, not extend something here and write it here. No, this is not correct. Everything should be placed around the drawing in a particular manner, not very far away. Okay, this makes it's look like if I put like this way and like this way, it will look like there is a spider here. That is not, that should be avoided. So that's why the drawing should be such a way that the lettering, the pencil, the use of line should be well represented. No ornamental, because this is a technical drawing. Like I said, you this is not an abstract drawing, so no ornamental or embellishing styles of letters should be used. Like like this way, or if I'm writing K like this way and like this way, no, because there are if you open a simple word file, we have different types of letterings. That is Arial, Cambella, and we have this Times New Roman, various types. Verdana. So various types of wording styles are there that should be avoided. A simple drawing is standard letters should be used always. Similarly, plain letters and numericals which are clearly distinguishable from each other in order to avoid confusion in case of slight mutilations. Why this word is important? What happens actually sometimes when we do drawings and when the drawing goes from one person to other person, so it is being handled because that is being drawn in a paper, so it becomes sometimes, we fold it, it has passed to number of persons to different hands actually. Sometimes the letterings and words they go, they are not sometimes as as good as that which was at present. So if anything has damage, small damage has been done to the drawing in any case of transportations or handling, the letters and numerical should be written in such a way that the message that we want to convey to the to the second person who is sitting 1,000 kilometers away from me, he should be able to understand even if there is a small damage drawn to the drawing sheet. So that is very much important. Now, based on the lettering, what we have is that in Bureau of Indian Standards 9609, we use single stroking letter. For example, if you have gone to the bank, actually, what happens in banks when you put a signature or any on check, for example, we have got a check like this way, and this is we have to pay amount of this 1 crores or something, and there is a sign signature for page here. It is always advisable to put your signature in a one go, right? Not that you put, okay, this one, I will have this one like this way, and then again this one, and this one, okay, this one like this way, this one, and this one. Okay, no, this is not correct. I will put like this one, and this one, okay, and this one. Oh, A should be like this. So this is not correct. So always the drawings and signatures are always drawn in a one go. It should not be actually drawn in a, just coming back and striking that, okay, okay, this is not correct, I will put like this. No. This is overwriting, and it could be easily captured in a by naked eye also we can capture it, that there is this overwriting. So a single stroke lettering is always used in an engineering drawing as it is used in every day-to-day life. The width of the stem of the letters and the numerical should be uniformly thick, and that should be so that for that one we need to have the proper way of holding the pencil and the tip of the pencil, which will give us uniform thickness. The word single stroke should not be taken to mean that the letter should be made in one stroke without lifting. No, that is not the what the word means. But it is actually means the thickness of the line should be obtained in one stroke of the pencil. So that is very much important. But I do not want to lift, even if I can go and lift behind, but it should not be such that I am altering the thickness of the line. Just go in one stroke or draw in one line, and the thickness should be as uniform as possible. Do not overwrite on those drawings. That is very much important. Now, lettering types. First is the lettering A. This is the lettering type, lettering A, where the height of capital letters is divided into 14 equal parts. The height is divided because even if one letter E, writing a letter E has to be divided in a specific way that each of the spacings between these lines and these lines, even if the subunit spacing which is present in between, that has to be also uniform. So height, the width, the thickness of each of the inclination, each of these lettering lines has to be actually very much standard. Even if the spacing between the bottom of these two lines, the bottom of these two letters which is written. For example, engineering drawing, how it is written, it has to be standardized. The height has to be uniform. And the same thing, if you want to write in a smaller, lower cases, then also there is a certain requirement that if I want to introduce a dot, there is a gap E. There is a gap, there is small gap B, and there is the height C, which is different from the height H. So I cannot go on representing this caps block letter, the capital block letters, the height the same as that of this one, or this vice versa. So there is this particular separation of this one, that block letters has to be given this much height. The running this lowercase letters has to be given this much height. So this is very much important. So if you have a lettering B, the height of capital letter will be divided into 10 equal parts. So there is a basically differentiation of lettering way of writing A and B, means this is a type. This is the way how the things are being written. The 14 equal parts division for writing a capital letter, and the similar letter B, where the capital letters have been divided into 10 equal parts. Now, based on this one, how the specification of letter A, that is type lettering, A type lettering is done. The capital letter height, which is H, that can start from 2.5, 3.5, 5, 7, 10, 14, 20. The lowercase height will be defined by a term that A equals to 5/7 of the height of the capital letter. So this is the thing that we have seen. Okay, okay. So can I do not know the name of this person. If anyone has asked one question through WhatsApp, so please can you unmute yourself so that I can understand your question. Original image of the object also provide 3D diagram to understand properly. So I'm sorry I do not recognize your name. Can you just unmute and let us know the question? Hello.
Yes, sir.
Okay, okay, we'll see what happened. So anyone who wants to ask that, I cannot understand. I do not have his name actually. Using image of the object, 3D image. Okay, I will try to. When we go to the examples, I will show you because what happens actually. So one of our students in the class has asked that provide original image of the object, also 3D diagram to understand properly and solve the problem. So what happens actually? What I can understand your concerns is actually. Let me go to that one. That slide. Now, for example, this one. What we are seeing is actually a 2D image. Okay. So the 2D image, what happens because we have various cutting plane lines. So what we will do is that this thing, okay, this thing will be actually projected here or downwards or left hand side in a such a way that we can see the image in a 3D way. Similarly, this image, when it is made in a three dimension, has to be projected in a three ways. Like we can represent in this way, one part in this way, and other part in this way. So in this way, we can represent all the parts in a way that we can see the objects in a three dimension. Will that part of the drawing what we are asking for is actually present in the second module where we actually go to the projection of drawings. We show the drawings in a 3D way so that the images which are given in a 3D that is converting a 2D ways to show or represent everything in a good aspect. So that is coming in the second unit. So this concern what you have raised about is very much welcome. So we'll be that part will be coming in the module 2. The person who has asked, I do not know his name. They just texted me. We will address this concern in the second unit. That is in the next class. Okay. So now, since we were going to the different types of lettering, what we have here is that this is the specific types of lettering. If this is a capital letter, we have certain dimension. And if you have a lower, if I want to write the same thing in a lowercase, my values will be height will be something like this. So A will be 5-7 times of the height. So this is already very less. So this will start with 2.5, 3.5 like this. The thickness of line will be 1/4 of the height. So this will be its dimension like this way. Similarly, spacing between characters, which is C, which will be 1/7 of the height, which will be like these values. And this is being calculated from this one. Means you put the values of H here, whatever the values you get, you put it here. So this is the standard capital height letter. If you want to write in the lowercase letter, this is the way. The spacings, how it is done. Minimum spacing between words, how it is done. So these are the specific formulas. So these things we need to take care when we are doing the drawing. Similarly, if we have a type B letter, okay, they have also got their own dimensions that has to be taken care of while writing the different types of letters. So let us go to the main thing is that the main title are generally written in 6 mm to 8 mm size, and the subtitles are written in 3 to 6 mm, somewhat lower, while the notes which represents the diagrams, dimensions figures are written in 3 to 5 mm. The drawing number in the title block is written in 10 to 15. So, sorry, 10 to 12 mm. So this is the various ways of representing. The title block, everything is a major part of attraction of a drawing. Why? Because in the title block, if I have drawn anything, if I've drawn X, Y, Z, anything, if I have not mentioned what is the object is about, if it is an apple, banana, or a monkey, or anything, it has to be specified there. You know, that is very much important, and it is being shown by a bigger letter size of 10 mm to 12 mm. So you can see figure 3.4, this is this one, shows single stroke vertical capital letters and figures with approximate proportions. You can see how this A, even if writing A has been divided into small units, grid squares. You can see. Similarly, C, D, E, F, G, H, like this way. Everything has been written with respect to certain grids. You move some like this way. I cannot have A written like this way. Okay, one line and one line coming like this. No, this won't be correct. Right? Even if I cannot write B like this way, no, this won't be correct. So there is a proper proportion to how to write A, B, and C and D. Although you do not have to strictly follow this one, but still the thing should look uniform throughout. You can see how the fractions are written in the grid points with the grid scales. So everything is being gridded here to write something in a drawing paper. This is very much important. Now this is another examples. If you want to write in a slanting lines like this way, so these are the various ways. You can see how the screens are inclined to do this writings. The smaller ones, A, B, C, D, you can see the difference. You can see this side and this side, how the differences are being made. It's very much important to show how the P, Q, and everything are falling behind this, internal lines, or they are falling outer of that one. So this is very much important to represent all the writings and numbers. Now, coming to the measurement units, generally what happens, the bigger unit is kilometer. We do not represent kilometer in a drawing sheet of dimension of around 600 mm. So we generally draw represent dimension in mm. The common unit, that is the SI unit for representing any drawing features in a engineering drawing is used with the help of millimeter. And also, if you want to, if you do not want to write everything in mm, for example, if this is a drawing, okay. Just I want to say that I draw an extension line like this way. I write this is 50, and I write this is as 100, and this is will be 50. This not to be representing, and this one let it be 50. So sorry, this should not be written like this way. You have to write like this 50. So like this way, we do not write mm in every cases. Just mention that all dimensions are in mm. That much, like this one. Bottom left, in the bottom left corner, outside the title box, you have to just write this one, all dimension in mm. So you'll understand that whatever diagram you have drawn, the dimensions are in mm. Now comes the thing that how to represent a bigger scales into smaller scales. That we will learn. That if there is a bigger scales that you have to represent in this smaller one, how the proportion has to be changed in order to represent this. But for the time being, all the dimensions what you draw here, draw according to one scale, and that is generally millimeter that we use in our drawing sheets generally, and that is being represented. You can write all dimension in mm without worrying about repeating the writing after every dimension that we have. So, so every diagram, whether there will be a scale, so how the dimensioning is done. So every diagram, whatever it is given to you, there is a two things that is very important. The dimensioning represents your scale, that is the length, breadth, height, the sizes, and position of holes or groups. And such as details are very much important for the manufacture of that object. So, so whether it be a scale drawing or a freehand drawing, the true shape of our objects will be represented by these very much features, the length, width, height, groups, or something. For example, in this one, what we have is here a bolt being present inside of a block of a part. So here what happens, we have the functional and locational datum. What is functional? These are the parts that is being present. That is the functional part which is very much required to determine the specific features. So that is being represented the functional part. The locational one means where the thing is present. This one. This is present here, so this is being represented by L. This is the functional because we need the dimension of this one. Similarly, this is the circle is located somewhat here, so this is the locational dimension or datum dimension. This circle is located here, this is the locational dimension. So this is the image what we see here. The image what we see. The top view image is this one. The top view image of this one is this one. This is the front view image, and if you see from the top view, it will look like this one. So there are these features, the locational features and this functional features, very much important to allow us to understand what are the things that is needed for a diagram of things to be represented. The NF is called non-functional features because we do not require that much of their dimension or anything. They are just a part of the auxiliary support to the part of that one. But the functional features are very much important because they represent the main basis functions of your or basic characteristics of your diagram.